but we may end up being 2 or 3 degrees warmer than pre-industrial, which everything points towards that being just catastrophically too warm. So our belief is that this third tranche of activity, solar radiation management, is required to keep temperatures at manageable levels.
Welcome. My name is Herb Simmens, and I'm here today at Baku for the COP29, and I'm delighted to be able to moderate a panel that's called Climate Engineering and the Napkin Diagram. And for those of you who have no idea what the napkin diagram is, you will know at the end of this session. This is being sponsored by the Climate Emergency Forum. Please go to our website, climateemergencyforum.org, and I'd also like to acknowledge the International Society for Ecological Economics for their support of this program. My own background is that I'm an author of a book called A Climate Vocabulary of the Future, and I'm also a co-founder of a group called the Healthy Planet Action Coalition. And we are an international group that basically has a much more ambitious, but we think doable goal of ultimately reducing temperature increases to well below 1 degree C, even though we're now at 1.5 or so degrees C, through what we call the climate triad there, removing, reducing, and cooling. And our panelists today will speak more about similar sorts of issues and basically present, I think, a different kind of paradigm for what we think should happen at COPs and in the climate conversations and actions throughout the planet. So basically, I want to start first by introducing Hugh Hunt, who is the Deputy Director for the Center for Climate Repair at Cambridge University there. Hugh is also a reader in engineering, and he was the co-principal investigator of the SPICE project, which investigated the feasibility of stratospheric aerosol injection for solar radiation management. And he's been a leader in public engagement on this issue for many years. Our second panelist, and those of you who follow the Climate Emergency Forum know him well, Paul Beckwith, who's a Canadian who's taught at the University of Ottawa in the Laboratory for Paleoclimatology, as well as at Carleton University. He's probably the most prolific climate educator on the planet, with well over 1,200 videos on YouTube. So with that as an introduction, I'm going to turn it over to my friend Hugh.
Thank you very much. The best way, in my view, to introduce climate engineering is through this thing called the Napkin Diagram. And John Shepard, who's sadly no longer with us, drew this diagram when he was sitting down with some colleagues at a meal. And as you do, you get a napkin and you scribble things down. And I've got my own version of this napkin diagram, which is the same as the one that you see on the screen in front of you. The idea is that time is on the horizontal axis and temperature is on the vertical axis. And time, it's quite a few long time scale, perhaps a couple of hundred years, during which, with business as usual, that's BAU, you'd expect temperatures to rise because we're burning more and more fossil fuels and more greenhouse gases accumulate in the atmosphere. If, as we ought to do, through the COP process, we reduce our emissions, then with any luck, the line curves down, and so that is step number 1, emissions reduction. And that is, of course, what we must do, and it's what we're here in Baku for, to try and see to it that we get emissions reduction as quickly as possible. But, it's taking longer than we might expect, so that curve is turning around at a gentle pace. In addition, then, we need to do carbon dioxide removal. That's CDR. That's the step number 2 shown on the napkin. And that step number 2 involves perhaps encouraging the oceans to absorb more CO2, or planting more trees, or direct air capture technologies such as those. And these are taking some time to develop. The scaling up is, it's going to take years, decades to scale this up. So that's step number 2 is essential, but it leaves behind a bump, a hump, an overshoot. And you can see then that who knows where that will leave us, but we may end up being 2 or 3 degrees warmer than pre-industrial, which everything points towards that being just catastrophically too warm. So our belief is that this third tranche of activity, solar radiation management, is required to keep temperatures at manageable levels. And some people will call this peak shaving, but whatever you might call it, you can see on that diagram the shaded area is solar radiation management. And we may need to do this for some decades, who knows, but we're pretty certain to need it. Emissions reductions alone is not sufficient. All 3 of these activities are required. And you might be wondering, what does solar radiation management look like? Well, this slide is by way of introduction, and we can talk more about this on the way through, but reflecting sunlight, solar radiation management. And reflecting sunlight can be done by perhaps producing whiter clouds. That's marine cloud brightening. And that's the one that's kind of in the middle of the picture, the big white fluffy cloud reflecting sunlight. And at the top of the picture, on the left-hand side, there's sort of the spotty, the spots up in the stratosphere. That is reflecting sunlight of particles that are injected into the stratosphere to emulate volcanic eruptions. And that is stratospheric aerosol injection. I'm going to leave it there and pass on to my colleague Paul, who will perhaps have more things to say on this very subject.
Yes, thank you, Herb, and thank you, Hugh. So why would we even consider things like carbon dioxide removal and solar radiation management? Well, the reason I think is pretty clear, that extreme weather events are accelerating around the world. We're actually accelerating fossil fuel subsidies, so of course greenhouse gases in the atmosphere are rising, and not only are they accelerating a rise, but there's an acceleration of the acceleration. And physicists call the derivative of acceleration the jerk. So greenhouse gases are skyrocketing, and of course we're seeing the warming effects, and people talk about 1.5, which is probably gone already. They talk about 2. Those are global average temperatures. Because the Arctic and Antarctic are warming much faster, we're getting a disruption of the way things move in the atmosphere, the way things move in the ocean, and resulting in all these extreme weather events. So it's pretty urgent, and we will pay for it very soon, one way or the other. Lots of people are paying for it now. Just ask people living in many cities in Spain, for example, or in the US where the massive hurricanes came through, or go to any part of the world. Everybody's being affected by abrupt changes to the climate and wacky weather systems. We're all in the climate casino, and you may not have been affected too much now, but you will probably be affected very soon, and nobody on the planet could escape that. So the urgency is much greater. So no surprise that this conference has a lot of discussion about carbon dioxide removal methods. There's even some, I just was at the World Oceans Pavilion, and there's some discussions on taking organic matter. Of course, trees absorb carbon dioxide, and they grow their fibers of the tree, and then when the trees die and the litter goes on the forest floor, well, that litter then decomposes, adding carbon back to the atmosphere. So you can actually take that carbon, the dead foliage from trees, etc., and you can put it, a group is looking at putting it on the bottom of the Caspian Sea in anoxic zones where there's no oxygen because there's very little vertical mixing in the water column, so that organic matter would stay at the bottom and be sequestered for a long period of time. Similar work is being done in the Black Sea, as I just discovered in a separate panel. So there's a plethora of conferences, side events, etc., discussions on carbon dioxide removal. Methane removal is probably even easier to do and more significant on the climate because methane is a much more powerful greenhouse gas. But this is still not quick enough. The problem is the natural sinks of the earth are failing. You know, the soils used to absorb vast amounts of carbon, and they're no longer absorbing vast amounts of carbon. We're losing large parts of the Amazon rainforest, which is a huge carbon sink, and that sink is turning into a source. The permafrost, the top 3 feet or meter of permafrost in the Arctic contains more carbon and would lead to more higher levels of greenhouse gases in both the atmosphere and ocean, you know, by enormous factors compared to what's there now. So the urgency is there, so we have no choice, I think, but to start researching and then deploying solar radiation management methods. Now, it's very controversial. There's a lot of people against it, but there's still a number of sessions now here at this COP talking about this technique. So, you know, in my view, it's going to be done. I mean, do we want to eat or do we want to deploy, you know, do we want to starve or do we want to deploy CDR? And SRM, and I would say we want to deploy all those things, and some of them are very easy to deploy and very inexpensive. I'm talking about sulfur in the stratosphere, for example. Inadvertently, we've been geoengineering this planet forever. You could argue that fossil fuel emissions is a geoengineering project we didn't intend on, changing the chemistry of the atmosphere and oceans, but that's what we've done. The International Marine Organization's taken sulfur out of shipping fuels. It's caused warming in the northern hemisphere over the oceans. Volcanoes go off, it cools the planet. So we know the climate system is very sensitive to sulfur. So if I had to bet, that's the method that I would bet on.
Thank you, Paul. It strikes me that I almost feel like what we're talking about is a bit sacrilegious here at the COP, that almost all of the emphasis, with a couple of exceptions, as you acknowledged, is on emission reductions, which of course is absolutely necessary. And my question to the two of you is why has there been so much opposition, fear, concern about bringing solar radiation management into the conversation? I happened to have the opportunity the other evening to speak very briefly, of course, with Al Gore, and I asked him about solar radiation management, and he looked at me with a frown. I mean, you know, Al has a very expressive face, and he frowned, and he basically said, no, it's a moral hazard there. It will stop us, slow us down. It'll give the oil companies another excuse not to have us reduce emissions as quickly as possible. Others have talked about adverse impacts, and of course, that's part of what you're researching at Cambridge. And questions about how in the world are we going to govern this? How do we collectively decide how we're going to make this happen and who's going to have the say? And all those thorny questions. So I guess my simple but probably challenging question to the two of you is, how do we take this conversation to the next step? How do we open people's minds to at least have an open-minded, objective discussion of the pros and cons without all this sort of fear and baggage that seems to exist right now? So let me start with you.
I think we probably ought to say that here we are in COP29, and it's taken 29 years to accept that burning of fossil fuels is the source of the cause of the problem. 29 years ago, it would have been possible to deal with the global warming as we were beginning to see. It would have been possible to deal with it by emissions reduction alone. And I think that the process has not shifted from this view that it's possible to deal with the problem by emissions reductions alone. And maybe where Al Gore has a problem is that it would require a change of face. It would require some kind of admission that, okay, we're going to need this stuff. And maybe he's just not like many people, not willing to take that step. I think also that politically, the COP process has, for a long time, been focused on emissions reductions as the way forward. And it does mean that governments are very thankful for the idea that, these NDCs are, all they need to do. The NDCs, all they need to do to do what the COP process has said, job done. Well, that's very convenient for the politicians around the world to be able to say that's all we need to do. So I think we're kind of stuck in those two issues. One is that the task has changed under our feet, and two is the COP process is very conveniently kind of ensuring that we don't change our strategies.
Yes, we need to consider and be concerned about feedbacks in the climate system. So there's a lot of very strong feedbacks that are going on. And one of the most concerning that's come up in the news quite a bit is the failure or the slowdown, perhaps even shutdown of the ocean currents, the AMOC, the Atlantic Meridional Overturning Circulation. And the probability just a few years ago was given as, this event may happen between 2025 and 2090, with low probability. Stefan Ramsdorf has been studying this at the Potsdam for 20 or 30 years, and he would wager now that the probability of this thing shutting down is something like 50%. If it shuts down, lots of the northern hemisphere suddenly goes into a deep freeze. You can't really grow much food in Europe. We would get global food shocks for sure. So do we really want to, we basically run out of time for emissions reductions. We've run out of, we're running out of time for carbon dioxide removal methods, so we have to go all out and use engineering to cool some parts of the planet to buy us time to proceed with our carbon dioxide removal methods and to proceed, or not even proceed, but begin to draw down the CO2 levels, reduce fossil fuel emissions. I mean, solar is growing at tremendous rates. It's doubling every 3 years, solar electric capacity. It'll pass nuclear in about a year. It'll pass wind in a couple of years. By, within a decade probably, it will surpass all other production of energy for electricity, just solar alone. So we've got these tipping points in how we're reacting to the climate system, but we've got, very, very severe tipping points that we're up against. And once something tips, then that's it. You're in a new state. You can't just lower emissions and go back to where you were before. So these sort of ideas of tipping points are very severe. So solar radiation management is a human tipping point that can try to restore our planet to some sort of stability of temperature, to buy us time to rapidly pull out carbon and reduce methane and cut emissions, because emissions are rising at ever accelerating rates. We're heading in the wrong direction despite all of these COPs. Now, you could argue, the COPs have been important because who knows what temperature we would be at right now if there hadn't been any COPs, right? It would be much higher than now, and we'd be, in much worse situation, so.
Hugh, I wanted to ask you, because Paul mentioned the AMOC. And that seems to be something that if people don't know about it, and I suspect everyone here knows about it, but most people on the rest of the planet may not yet, is one hates to be fear-mongering about the catastrophes that may await us, but certainly the latest research, as you say, suggests that there's a high probability that it may collapse. And I guess my question is, what do we know about the potential of solar radiation management to delay or minimize or avoid a collapse of something like the AMOC? And what else do we need to do to get to the point where we can say we're confident that it can or it cannot?
The kinds of things that solar radiation management can do, well, it's the subject of research. And one of the issues that we face in the world of geoengineering is that it's deemed to be controversial, and so controversial that there have been plenty around the world that have said that research into geoengineering should be banned. Now, I quite understand why you might want to be very cautious about deploying geoengineering, but research is absolutely essential to begin to answer the questions, Herb, that you've just asked. We've done quite a lot of computer simulation, computer modeling, but we know what computer modeling is like. It gives us ideas, it gives us hints. We've got to be out there validating these models to be able to answer the questions of what will the impact of SRM potentially be, for good and for bad. Now, we've been constrained. We're not allowed to do outdoor experiments. What I think the direction that SRM will go once we decide that we need to do outdoor experiments and outdoor verification and validation is we will learn by doing. And we will find what kinds of things perhaps we'll be surprised. Oh gosh, this SRM is really being much more effective than we expected. Or it may turn out not to be, or it may turn out to be so unreliable and risky that we may decide, no, we can't do it. But that's why we need to do the research. But my guess is that SRM will have the potential to slow down the melting of the Arctic sea ice and to slow down the melting of glaciers, and the cold, fresh water that's getting into the warm, salty Atlantic is driving changes to ocean circulations. So I think that the SRM might not directly impact AMOC, but it will indirectly make a big difference by preventing the Arctic from warming up rapidly.
Thanks, Hugh. And I think that's a very important statement you just made, that there is a significant potential, subject to additional research and field testing, that SRM may be able to help minimize those risks. And why in the world will we not do everything we could to find out the answer to that question in time, not just to do it, but in time? And very briefly, Paul, and then we're going to take a couple of questions.
I just wanted to say that, we generally trust engineers. Like, I'm wondering if, a couple hundred years ago, the public was totally against building roads, building like paving roads and starting to, were they against bridges and boats and any new technologies? I mean, engineers in today's society are highly trusted. I mean, they build the infrastructure which we use every day. They build our phones, they build our roads and bridges and sanitary systems, buildings, everything. Right? So they're highly trained and they have very strong ethical principles. So here we're talking about some scientists doing research on these methods, some engineers setting up small-scale experiments and deploying them, and we see what happens. And if they don't work, we go to something else. But the point, they're trying to stop these engineers and scientists from doing something that could help society in enormous ways. If successful, then, we have to proceed and trust engineers.
Thank you. Are there any questions from the audience? It looks like we've got a couple of hands up. This gentleman here. Please introduce yourself.
Yes, thank you very much. Axel Michaelova from Perspectives Climate Research at the University of Zurich. Actually, at Perspectives Climate Research, we have currently just started a research project under the Horizon Europe program on how to regulate research on SRM. And my question to you, of course, you have faced the public criticism on the SPICE project and suffered. What would you recommend to increase the faith of the public that we are not trying to do nasty things, but that we want to really understand what would happen, for example, if a rogue dictator would suddenly implement SRM?
The SPICE project wasn't going to inject any reflective material at all, and yet the project got cancelled. We have to be more bold and say we're going to need to do experiments to validate the models, and we keep the scale of the experiments down, for instance, to 1/1,000,000th the full scale, where they can't have a climate impact. And we simply must be bullish and say we're going to do it because we have to do it.
Thank you. We have time for one more question from this gentleman here.
Bob Berwin with Inside Climate News. I'm going to ask a couple related questions. I hope that's okay. Is there actually a ban anywhere on modeling research, on geoengineering? And is there any modeling study, peer-reviewed, that shows that this could be done without disrupting the Asian monsoon? I mean, do you have any research that's a basis for saying that you could do this safely? And shouldn't that be done first before even talking about it?
So the question about whether SRM might interrupt the Indian monsoon, for instance, well, look, it might. And if that's the kind of thing we need we've got to be really careful about that. We have to do the research. There's nothing stopping us in principle from doing research, but there's a great nervousness that environmental groups will come in and shut us down.
We've got to running out of time. I want to thank everybody. This was a great panel. We hope you'll look at it and you'll recommend it to your friends. For more information on the Healthy Planet Action Coalition, healthyplanetaction.org. Please go to the website for the Cambridge Center for Climate Repair as well. And thanks to everybody today here at COP.
And out of curiosity, if you Google napkin diagram, it's the first thing that comes up.
Thanks again, everyone.